Hello, welcome back once again. Today we're going to integrate 1 over x to the power of 4 plus 1 dx. But in this video we're going to make use of what we call the brute force approach. Okay? So let's see how this is going to help us. Now we have to integrate. Let's call it I is equal to the integral of 1 over x to the power of 4 plus 1. There's something really cool we need to do about this denominator. Let's take note of the following. We have x raised to the power of 4 plus 1. We should know that this is same as x to the power of 4 is same as x to the power of 2, then raised to the power of 2, and then plus 1. Now let's take note of the following. We know that I squared is equal to negative 1, where I is an imaginary unit. So this is going to be equal to x to the power of 2 whole squared. Now we're going to have a negative sign here, since we know that I squared here is going to give us negative 1. So x to the power of 2 squared minus 1 is giving us x to the power of 4 plus 1. You get the idea? Now we can see this is clearly the difference of two squares, which we're going to make use of this nice identity. That a squared minus b squared is equal to a plus b multiplied by a minus b, right? So here, x to the power of 4 plus 1, which is same as x to the power of 2 whole squared minus I squared. This is going to be equal to x squared plus I, then multiply by x squared minus I. This is cool. So our integral I is going to be equal to the integral from, it is an indefinite integral, right? So the integral of 1 divided by x raised to the power of 4 plus 1 dx, this is going to be equal to the integral of 1 divided by this product x squared plus I multiplied by x squared minus I, right? And then we have dx. Now take note of the following. Remember, at the numerator we have just 1. Think about this. When x squared plus I minus x squared minus I, what is this going to give us? Clearly you can see that this is going to give us x squared plus I minus x squared minus I, giving us 2I. And don't forget that at the numerator we have 1. So 1 can be written in the form 1 divided by 2I, then multiply by, then the difference, x squared plus I minus x squared minus I. This is cool. So here I is going to be equal to the integral. At the numerator we just have 1 over 2I, then multiply by the difference between this x squared plus I and x squared minus I. And then don't forget, we're dividing everything by x squared plus I multiplied by x squared minus I. And then we have our dx. Now we're going to split the denominator. So I is equal to, splitting the denominator, we get the integral of 1 divided by 2I multiplied by, this is going to be x squared plus I, then divided by x squared plus I multiplied by x squared minus I. And then we have to put our dx. Then remember there is minus right over here. Okay, so it's going to be minus the integral. We're going to have again 1 divided by 2I multiplied by x squared minus I, then divided by the product x squared plus I multiplied by x squared minus I. And then we have our dx. And clearly we can see some nice cancellations going on, right? So here this and this get cancelled, and from here this and this get cancelled. So therefore our I is going to be equal to 1 divided by 2i outside. Then we have to integrate 1 divided by x squared minus I dx. Again minus here 1 over 2i outside. We have to integrate 1 divided by x squared plus I, and then we have our dx. Now we want these integrals to look similar to these standard integrals. We know that the integral of 1 divided by x squared minus a squared dx, that this is equal to 1 by 2a multiplied by the natural log of x minus a divided by x plus a, right? This is cool. And don't forget our constant. So, and again, we have the integral of 1 over x squared, then we have positive a squared dx, that this right over here is equal to 1 divided by a multiplied by the inverse tangent of x by a, and then plus c. So how exactly are we going to make this denominator to look similar to this? We have x squared minus a squared, but here we have x squared minus I. The I is not squared. I think we can do something really nice, right? And also this place. So this is what we're going to do. So our I is equal to 1 divided by 2i multiplied by the integral of 1 divided by, so here x is squared minus, now I is same as when you take the square root of I and then you square it. Oh, this is cool, right? And again we have minus, is that minus? Yeah, minus 1 divided by 2i multiplied by the integral of 1 divided by, here the same thing, we have x squared plus I, which is same as square root of I, and then squared. Then we have our dx. So we can make use of those standard integral formulas, right? So here we get I will be equal to 1 by 2i, and don't forget we're multiplying by 1 over 2 root of I times the natural log of, this is going to be x minus square root of I divided by x plus square root of I, and then minus 1 by 2i multiplied by, this is going to be 1 over root I. Then the inverse tangent of x divided by square root of I, and then plus c. This is what we call the brute force approach, but it is going to involve the imaginary units I everywhere. So here we're going to simplify nicely. So we know 1 over, let's take note of this, 1 over square root of I. When you multiply by square root of I divided by square root of I, you're gonna get square root of I divided by square root of I times square root of I is same as square root of I squared, and that is leaving us with only I, right? So that is what we have right over here. So remember we have 1 over 2i multiplying by this, so it's going to give us negative 1 at the denominator. So we're going to have negative square root of I divided by 4. Don't forget. Then we have natural log of x minus the square root of I divided by x plus the square root of I. And then here we have minus, oh, we're going to have a plus sign, right? Remember what is going on there. This is going to be square root of I. Then this time around, we're going to have only 2. Then multiply by the inverse tangent. Oh, sorry for that. So multiply by the inverse tangent of x divided by the square root of I. And don't forget, we have our plus c. So this right over here is our solution, and that was cool. Thank you for watching. Please, if you really enjoyed this video, kindly support this channel by subscribing Also like, comment and share.